You may find that you often need to update one element with information from another element. Perhaps you want to display information from a collection of objects in a list or combo box. Or perhaps you need to work with data from a database. In all of these cases, the simplest solution is to bind data from a binding source to a binding target. In other words, we need some way to perform binding, whether it's from a property of one element to a property of another, from a collection of objects in memory to an element, or from a database to controls on a page. We need some way to bind from a source to a target. When would you use binding? Maybe you want to display the number of characters in a text box in a text block control. Maybe you want to display the value of a slider control in a text block. Or display a list of customers in a list box. Maybe you want to display a customer's photo in an image control coming from a database record about that customer. Maybe you want to display and edit a customer's name in a text box. Of course, there are an infinite number of reasons to use binding. In this section, we'll look at a small subset of the kinds of things you can do with element-to-element data binding. Binding is all about connecting sources and targets. Every time you use binding, you must supply a source for the data and a target for the data. Normally, the target is a dependency property of some user interface element. This diagram explains how this works. The binding source can be any CLR object where we want to take a property of that object and use it, on the left-hand side here, in the binding target. The binding target will be a framework element and will bind to a dependency property. The object that does the work is the binding object in the middle. The binding object takes the value from some object and assigns it into a property of some other object. Along the way, optionally, you might use a value converter to convert the value from one type to another, or just modify the value as you do the binding. That value converter can be invoked in either or both directions. The arrows all here have double-headed arrows, so you can do binding from a source to a target, and then take the value from the target and send it back to the source. The binding source can be any property of any CLR object. The binding object connects the source to the binding target, which must be a dependency property of some framework element object, at least for the kind of binding that we're doing. Under the hood, when you use binding in XAML, you create an instance of the binding class, setting various properties that affect the behavior of the binding class object. XAML provides a binding markup extension. You may have seen this before, and it does simplify the syntax. It hides the fact, but it's still working with a binding object. And this is completely transparent if you create the binding object in code. You can set the mode property of the binding to control the direction of the data flow. You can have the data flow in one direction or both directions. The value converter block in the figure represents an instance of the class that implements the system.windows.data.iValueConverter interface. Doing binding declaratively in XAML often requires a value converter because you're trying to move data, for example, from an integer into something that requires a totally different type, or from a string into something that requires a totally different type. In that case, you have to write code in a value converter to do the work for you. For example, maybe you want to select a customer from a list box and display the combined first name and last name fields in a text block. Maybe you want to select an integer, a single integer, and bind it to the border thickness property of a border control, which requires a structure with 4 elements. You can't bind it directly because border thickness is a thickness structure, not an integer. Again, there are infinite reasons to use a value converter, but you'll only need it if you're binding declaratively, that is, in the markup. If you're writing code to do the binding, then you can just write the code to do the conversion there. Let's look at a few simple examples that demonstrate using binding. I've run the sample project for this section, and as you can see, it's a series of tabs containing user controls again. And here I have a slider, and as I move the slider, I place the value of the slider into the corresponding text box. I'm doing this without using binding, and you can see right here how that works. We have the value changed event of the slider reacting to the value being changed, and then for each time this occurs, we take the value of the slider, convert it to a string, and place it into the text property of the text box. And every time you see a line of code like this, your brain ought to go, perhaps this is a good place to use binding. Well, let's look at an example that does use binding. Simple Binding 2 does this without a single line of code. As I move the slider, the value gets placed into this text box. How is that working? Let's look at Simple Binding 2, this one. And if I look at the code for this, you'll see no code. How is this happening? If we look at the XAML markup for this, you'll see the text property of the text box has a binding expression. The binding expression says take the element name demo slider, take the path value, and this indicates we want to take the value property of the demo slider element and assign it to the text property of this text box. The plumbing all happens under the covers. All you have to do is create that markup extension which defines how we want to bind the text property of the text box and to what property of what other object we want it bound. As you saw, it works without a single line of code. The standard binding markup extension includes the element name and path attributes, like this. You saw the text attribute of the text box equals binding, element name equals demo slider, path equals value. The path attribute is not required, so you can move it in front. This is how you often see this specified. Binding value, comma, element name equals demo slider. So they'll assume that value represents the path if you see a syntax like that, and you can choose whichever one you like. The path property can refer to a property, or a property of a property, or even an indexed property, or even an indexed property. If you need to refer to an attached property like grid.row, in that case, you'll set the path property to grid.row in parentheses. The reason for that, of course, is that property doesn't really exist on the element name you've specified. It exists elsewhere, and the parentheses indicate that it needs to go look elsewhere for the value of that property. The binding markup extension is just a shortcut for child element syntax. So here, if we took that last example and recreated it using the child element syntax, we would see that the textbox.text property contains a binding element whose element name attribute is demo slider and whose path is value. You can do it either way. This is much clearer, but the markup extension requires less typing, of course, and it allows you to specify that binding in a single attribute without having to use a new element, a child element, as in this example. Now, in the previous demo, data moves from the slider to the text box, and only in that direction. Changes you make in the text box have no effect on the slider. In other words, the binding is one way. The data moves only in one direction. You can set the mode property of the binding to change that behavior. We have never set the mode property. We've only set the element name and path properties, but the mode property exists, and you can set that property to one of these values. One time means the value is only set one time and then never looked at again. If we had set our mode to one time in the last example, we would have 0 in the text box, and the value would never change after that. One way indicates the data moves only from the source to the target, and that's the default, and that's what we had in our previous example. Two-way moves the data in both directions. That is, if we change the value of the slider, the value of the text box text property updates, and if we modify the text property of the text box, it would update the value of the slider. You can also set the mode to two extra settings. One way to source provides one-way binding, but only from the target to the source, and default, which uses the default settings for the object. Let's look at an example now that uses two-way data binding. In this example, Simple Binding 3, it looks pretty much the same. I move the slider, the text box updates, but now watch what happens if I type a value into the text box. You can see that by entering a value into the text box, and I press Tab to leave it, at that point, we update the slider's value as well. Let's change this to 9, for example, and we update the slider. So I can either move the slider to update the text box, or update the text box to move the slider. How is that working? Well, you can see it right down here. We have the text attribute of the text box has a binding expression which indicates that the mode is two-way. As opposed to the default, which is one-way, two-way binding allows us to update from the text box back to the slider. Even though we're retrieving the value from the slider, we can update it by setting the mode equal to two-way. Here's another simple example. Perhaps you want to enter text into a text box and update a text block with the length of that text. You could react to the text changed event of the text box, but better is to bind the text property of the text block to the text.length property of the text box. This also points out that binding can use expressions. Text.length is a perfect thing to bind from into the text property of the text block. It also points out that there are some internal conversions going on, because the text property of the text block is a string, and text.length property of the text box is some sort of integer value. Therefore, someone, somewhere, is converting that integer into a string for you to do this binding. You'll find that there are some internal conversions, like this one, that happen for free. Let's look at the example and look at the binding expression to see how it works. In the user control Simple Binding 4, as I enter text into the text box, you can see the length of that text automatically appears in the text block to the right of the text box. How did that work? Well, let's look. Here's the text block element right here. We have its text property set to a binding expression which takes the text.length property, and this is using the syntax where you don't explicitly set the path, you just specify it as a piece of text sitting there, comma, element name equals demo text box, which means we get the text.length property from this text box and assign it into the text property of this text block. This is one of those cases where two-way binding makes no sense at all, because you could never modify the text property of the text block interactively. This should and always will be a one-way data binding.